Another way to use the linear regression equation is if you're given the output, and the output in this case is the number of customers. So let's say hypothetically you wanted to know, all right, 80 is the lowest amount of customers I have. What temperature do I need to have, or when should I keep the shop open versus close because I want to keep at least 80 customers in the store, or it's not worth it to have the doors open. So in that situation, if you're given the output, just a quick little reminder, X is my temperature and Y is my number of customers. So if I know I want to have 80 customers, then I'm going to plug an 80 in for Y right there. Okay. And now to solve this equation, to find out what temperature that needs to be in order to keep at least 80 customers, I need to solve for my X. So put a little box around my X right there, which means I need to get rid of the 0.687 and the 41.158. Now, when you're solving an equation, you're taking the order of operations, PEMDAS, you're taking it apart. So you're going backwards. So you're going to start with anything that's added or subtracted to your X first. In this case, our 41.158 is being added to our X. So to get rid of it, we want to subtract. And now in algebra, whatever you do in one side, you have to do to the other. So if I subtracted once over here, I got to come over here and subtract off 45.158. Okay, so now if I subtract that, 80 minus 41.158, that gives me 38.842. And I get 0.687x. Okay, now x is still not by itself. We have 0.687 there, and 0.687 is multiplying with x. So if I want to get rid of the 0.687, I have to do the opposite operation, which is divide. So I'm going to divide by 0.687. And if I do it on one side of the equal sign, I've got to do it on the other side as well. And so when I divide that by 0.687, I end up getting 56.5. And again, because we're looking for the x, that means degrees. So essentially what that means is that for temperatures 56 degrees and above, you should have approximately at least 80 customers in your store.